So I know what you're thinking, but what if it's not an acute angle? What if I can't draw a triangle? We can always draw a triangle. So if I'm looking for trig function values of an angle, of any angle, and not necessarily an acute angle that I can fit conveniently inside a right triangle, so any angle, I'm going to start from the positive x-axis and go around counterclockwise. So my angle happens to have positive measure, and I'm going to stop somewhere here in quadrant 3, and I want to know the 6 trig function values for that angle. I can't put that, I can't put a non-acute angle inside the triangle. But what we can do, math people love to do this, I'm going to turn this into a problem that I already know how to solve. I'm going to locate a point on the terminal side of my angle. That's a point, so it has coordinates x, y. Since I'm in quadrant 3, x and y are each going to happen to be negative. If I'm in quadrant 1, they were both positive. For 2, x is negative and y is positive. For 4, x is positive and y is negative. That's just the way the coordinate system works. So happens to be I'm in quadrant 3. Those are both negative numbers. And I'm going to make a triangle. My triangle is going to have one leg in the x-axis. The y-axis does not get to play the triangle game. It's just hanging out here by itself. I'm going to draw my triangle so that I have one leg in the x-axis. That's a right triangle. I went perpendicular to the x-axis there. Well, I know this side. It's x. If the coordinates of this point are x and y, this length here is x, complete with its sign, S-I-G-N. This side here is y. I just need to find the hypotenuse. We can do that. That's what Pythagoras is for. We're going to call it r. We know x squared plus y squared equals r squared. Little rearranging, and we get that, the square root of x squared plus y squared, and I'm going to call that r. And I'm going to find the 6 trig functions of my angle are the same as the 6 trig functions of the angle that's in here by the origin, the reference angle. And here we go. The sine, I'm going to name it. Actually, it's hard to talk about things that don't have names. I'm going to name it theta. That angle is theta. So the sine of my angle theta is its opposite side over the hypotenuse, same as always. That would be y over r. The cosine is the adjacent side over the hypotenuse. The tangent, as always, is opposite over adjacent. And the 3 reciprocals, flip them over. And there they are. There are the 6 trig function values of my angle that happens to be in quadrant 3, but could be in any quadrant. This will work no matter what. If it's useful to you to draw the picture, draw your reference triangle with one leg in the x-axis and set it up that way and look at opposite adjacent hypotenuse, go for it. Do it that way. If it's useful to you to just remember sine of theta is y over r, you can do it that way. You can do it without the picture if you want to. Here's y. We calculated r. Sine of theta is y over r. So whichever way you like better, whichever one you're more comfortable with. But we can use this method to find the 6 trig functions of any angle.